Welcome students. Here I come with my new video today, and today we are going to discuss about this topic, quadratic equations. I think many of you are familiar with this term quadratic equations, right? So what is quadratic equations? So let us discuss. It is actually a polynomial equation having degree 2, right? So all those polynomial equations which are having degree 2 are called quadratic equations, or you can simply say that if the highest power of the variable in an equation is 2, that equation is known as quadratic equation. I have written one thing here, the general or standard form of a quadratic equation. Generally, a quadratic equation, how a quadratic equation looks like, right? So general or standard form of a quadratic equation is ax square plus bx plus c equals to 0. So if I write only ax square plus bx plus c, that expression is known as quadratic expression. But if when we use equals to there, so that expression is known as equation. That is the difference, right, between expression and equation. In an equation you will always have equal to sign, okay. So ax square plus bx plus c is equals to 0 is a standard form of a quadratic equation. Now what is ABC here? ABC are constants, they are real numbers, right? So ABC can take any real values, but about A can take any real values, A can be any real values, any real number, but it should not be equals to 0. Why? Why A should not be equals to 0? Because what is A? A is actually coefficient of x square, and because of x square, this equation is quadratic. So if A becomes 0, then what will happen? This part, this x square part will be vanished then, right? In that case, this equation will no longer remain quadratic, it will become linear equation, right? So in order to be a quadratic equation, there should be x square, right? So if A will become 0, then that equation will reduce to linear equation and it will no longer remain quadratic. That is why A can take any real values, but it should not be equals to 0. Clear? Now based on this concept, when the equation will be known as quadratic equation, we have one exercise in NCERT, okay. So let me show you first the exercise, then we are going to solve that exercise, okay. So here we have on your screen, let's see. So this is exercise 4.1 of NCERT maths. Now see, this exercise we are going to solve. So what we have, how many questions are there in this exercise? We have 2 questions, question number 1 and question number 2. In question number 1 we have 8 subparts, and in question number 2 you can see subpart 1, then we have subpart till 4, okay. So let's solve the question. So we got the task right now. Now what is the first question? The first question is check whether the following are quadratic equations or not. So in these 8 questions, what we are required to do, we are required to check they are representing quadratic equation or not. So in that case, what is the concept? What is the concept required? The same thing, if the coefficient of x square will become 0, if there would be no x square, then that equation will, we can't say that equation is a quadratic equation, that equation will be linear equation. So if there is x square, that equation is quadratic equation. Or you can say, if a equation can be reduced in the form of ax square plus bx plus c equals to 0, that equation is called quadratic equation. We can say that equation is quadratic. So let us check, okay. So here we have the solution. So this is, here we have the exercise 4.1, first part for part 1. What we have as given, so here we have x plus 1 whole square is equals to 2 in bracket x minus 3. Okay, so what I have done, expand x plus 1 whole square. What is the formula? A square plus 2b plus b square. So I got this one. So see, 2x get cancelled. Why? Because if we take this 2x to LHS, it will become minus 2x, and plus 2x minus 2x will become cancelled. So what is left? So we have then x square plus 7 is equals to 0, which can be written like this: x square plus 0 into x plus 7 is equals to 0. Why I am writing like this? Because I am converting this equation into the form of ax square plus bx plus c is equals to 0. If x is not there, no problem, that equation will remain quadratic, but x square is not there, then in that case we can say that equation is not quadratic. So here this equation, which is in the form of ax square plus bx plus c is equals to 0, hence it represents a quadratic equation. Simple. Understood? Now let us do sub part 3. So in sub part 3, what we have as given, you can check in the exercise, we have this one in question number 3. So given x minus 2 in one bracket, then x plus 1 in other bracket is equals to x minus 1 in one bracket and x plus 3 in another bracket. Bracket represent what in maths? They represent actually multiply. What is there between these two? Between these two there is multiply. So I have multiplied these two one. So I got this. Similar thing I have done with the RHS. So see, x square get cancel each other. Why? Same thing, if we bring this x square to LHS, then plus x square minus x square will cancel each other. So what we left? What is left then? 3x minus 1 is equals to 0, which is a linear equation, of course. This is not a quadratic equation. So this cannot be, which is not of the form ax square plus bx plus c is equals to 0. Now you might be thinking, sir, you can write 0 into x square plus 3x minus 1 is equals to 0. 0x square. So again that concept arise. If I convert 3x minus 1 in this form, then I need to write 0 into x square. But as I told you, a can never be 0. Otherwise, if it will become 0, that equation will no longer remain quadratic. That is why for this we can't write like that, which I have written in the previous question, 0 into x. We can write, because as I told you, b, c can take any real values even with 0 also, but a can take any real values except 0. That is why. Now let us do question number 2. So first read. So I have solved only 2 subparts of question number 1 and 3, and based on the same concept you are going to solve rest of the parts. I hope so. Now what we have in question number 2, let's read the statement first. In question number 2, what we have, represent the following situation in the form of a quadratic. Represent the following situation in the form of a quadratic equation. So this question is same like which we have done in linear equation. First we need to frame, how to frame the pair of linear equation in 2 variables, right? So this topic is similar with this one, but here we will get a quadratic equation instead of pair of linear equation in 2 variables. Okay. So what is the first question? In first question we have the area of a rectangular plot is 5 to 8 meter square. Length of the plot in meter is 1 more than twice its breadth. Read this statement carefully. 1 more than twice its breadth. Now we need to find the length and breadth of the plot. Okay. So in that case, here you are not required to find the length and breadth, just you need to represent the following situation in the form of quadratic. So let's see how I have solved. Here we have, so since in that question one statement was there that its length is 1 more than twice its breadth, right. So I have taken, let the breadth of the plot be x meter, okay. So according to question, therefore what will be the length of the plot? It was written there one more then twice its length. One more means plus 1, twice its length, breadth means 2x. So it will be 2x plus 1 according to that statement. So area of the plot is given. Now by the problem, can I write this? Because length into breadth is area of a rectangle, right. So length is x, breadth is x and length is 2x plus 1 is equals to 528, and after multiplication and taking whatever is there in RHS to LHS, I got this equation. So if we solve this quadratic equation, so in the next exercise we will be having how to solve quadratic equation, okay. So we will discuss there. So if we solve this equation, we will get x, that means we will get breadth, and as once we got breadth, we can find what is length, okay. So we are not right now we are not required to find x, because in this question just you need to represent the given situation in quadratic form, understood. Now let's see which part I have done. Okay, part 3. Now to part 3. So what is the question to part 3? Let's see. So in question number 2 part 3, what we have? Rohan's mother is 26 years older than him. The product of their ages in years is 3 years from now will be 360. So product of their ages is not 360. 3 years from now, that means after 3 years the product will become 360. We would like to find Rohan's present age. So let the Rohan's present age be x. So therefore his mother age will be what? 26 years older than him. That means x plus 26. So let's see how I have solved. Here we have. So let the present age of Rohan be x years. So according to the question, Rohan's mother age will be x plus 26 years. Now by the problem, what is given there? One more information is there, that their product of their ages is 360, but not during that year, after 3 years, right. So now Rohan's age is x, right, which I have taken, which I have considered. What will be his age after 3 years? It will be x plus 3, obviously. Now what will be what is the present age of his mother? X plus 26. So what will be the age of his mother after 3 years? So it will be x plus 26 plus 3 will be added. 3 will be added. So this product by the question is 360. Understood? So after simplification, multiplication and all, I got this quadratic equation. So if I solve this quadratic equation for x, we will find what is the present age of Rohan. Now the last sub part, number 4. So what we have? So in this we have a train travels a distance of 180 kilometer at a uniform speed. So distance is given 480, not 180, sorry, 480 kilometer. If the speed had been 8 kilometer less, then it would have taken 3 hours more to cover the same distance. It is obvious, when the speed is less, time taken will be more. So what we are required to find, we need to find the speed of the train. We need to frame a quadratic equation from where we can find the speed of the train. So let's see. So let the speed of the train be x kilometer per hour. Let the speed of the train. So how I have solved, see. So let the speed of the train be x kilometer per hour. Okay. Now what is the distance traveled by the question? It is 480 kilometer. Now time taken by the train, what is the formula to time taken? Distance divided by speed, right? So distance is 480 and speed is x. So 480 divided by x r, this is the speed. Now according to question, if 8 kilometer per, if the speed of the train had been 8 kilometer per hour less, that statement was there, right? So according to that statement, what will be the new speed? Initially it was x, now 8 kilometer get reduced, 8 kilometer per hour, so x minus 8. So in such case, what will be the new time taken, because distance is same, new time taken, so same thing, distance divided by speed, new speed. Now initially the time taken was the time taken by the train was 480 by x. Now the time taken by the train after reducing the speed is this one. So what by the problem, can we say by the problem the difference between these two time taken is 3, because by the question it is written there that 3 hours, it will take 3 more hours, right? So that means the two time taken when the speed was x and when the speed becomes x minus 8, the two time taken, there is a difference between these two time taken which is 3 hours. Okay, so that is why by the problem can we write this. So when you are writing this one, so let me tell you, there is a possibility that you can make mistake. Now how do we subtract? Tell me. We subtract smaller one from the larger one, right? So in these two term, which one is greater? Tell me. If denominator get reduced, that means this one is greater. So greater minus smaller, remember this. So this one is greater. So greater minus smaller is 3. So the time taken by the train when the speed get reduced by 8, and initially when it was 3, the difference between the two time taken is 3. Okay, that is why we have by the problem this equation. So I have taken 480 as common, then after simplification you can check the simplification, you know the simplification I think better than me. So I got this equation. Okay, so with the help of this equation we can find x, which is the speed of the train. So I do hope that you have understood this session, how to frame quadratic equation, how to know the given equation is quadratic or not. So based on these two concepts, we have solved one exercise of your book, exercise 4.1. So we will do next exercise as well, exercise 4.2, where you will know how to solve the quadratic equation by different methods. Okay, thank you. And one more thing is there, that you are required to do the rest of the sub parts as well by your own. If there is any confusion or any doubts, don't hesitate to ping me up. Thank you.